we will see the remaining addressing modes possible with 8086. The first one is the indexed addressing mode or register relative addressing mode. So in this addressing mode, the offset within a particular segment is given as the sum of a displacement value and a specified register. Okay, so these are the possible options that we have. The specified registers can be either BX, BP, SI and DI, and the displacement values can be 8 or 16 bit registers. Okay, and as we have seen earlier, if we are using BX, SI or DI, the default segment that we are going to operate on will be data segment, and if you are using BP, it means that we are going to operate on stack segment. So this is a particular instruction that we are going to see. So it is we are trying to move something to the AL register, right, and the offset is given by displacement and a BX combination. So as it is BX and it is the base register for data segment, we are going to find the offset within the data segment. And how do we find that? We take the content of BX, right, then we take the displacement value, add both of them together, so it will give us an offset within data segment. It will be pointing to our operand, and that operand is moved to AL. Okay, now suppose that this is our particular combination. We have to move something pointed to by displacement as well as BP. BP is the base register for stack segment, so the offset is going to be within the stack segment, and it is given by the sum of the contents of BP and displacement, and it is found out then within stack segment, and the content is moved to AL. Then if you need to alter the default segment behaviors of BX or BP, it's always possible by using segment override prefixes. So here what has been done, here in the first case, BX usually operates with our data segment, but if you need to operate it with stack segment, SS segment override prefix can be given. And the next variant of the addressing mode is the based indexed addressing mode. So in based indexed addressing mode, two combinations of registers are used in indirect addressing mode. So there will be a base register as well as there will be an index register. So we know that BX and BP are the base registers in 8086, and SI and DI are our index registers. So the offset will be distributed across these two registers, and it will give us the final operands offset. So these are the possible combinations possible in 8086. So let's see an example. Here we are trying to move a content to AL, and its offset is pointed to by BX and SI, or it's given by BX and SI. So here BX is the base register, SI is the index register, right? So BX by default, as we know, will point to our data segment. So this offset given by BX and SI is going to be within the data segment. And how is the offset calculated? Offset is calculated by taking the BX content, taking the SI content, adding them together, and we will get the offset. So this offset points to an operand, and that operand has to be moved to AL. Now considering another case where our operand is offsetted or located by BP and SI. So BP is the base register for stack segment. So this offset is going to be located within the stack segment, or the operand is going to be located within the stack segment. And how is the offset calculated? It is again the sum of the content of BP and SI. So operand is calculated based on the offset within SS or stack segment. Then the operand is moved to AL. So that's what this instruction does. Then the final variant is based index plus displacement. So it is a direct modification of our based indexed addressing. So if you see here, this is a possible instruction. So this part is our based indexed, and to that if you add a displacement, it will give you based index plus displacement addressing mode. So let's see or analyze this instruction itself. So if you see this instruction, first we need to know on which segment this instruction is going to operate, right, or where are we going to get the operand from. So if you locate the base register here, it is BX. So BX is the base register for our data segment. So we are going to operate on data segment, or the offset is going to be valid within the data segment. So how is the offset calculated? Take the content of BX, take the content of SI, and add it with this displacement value as usual. Okay, so you will get the final offset to be used within the data segment which points to the operand. Okay, take the operand and move to AL. So that's how this instruction operates. Now let's see another variant. So here again it's a move instruction, and the base register used here is our BP. So as it is BP, the default segment will be stack segment. So we are going to find the operand within the stack segment. So an offset value is valid within the stack segment, or it is to be used with stack segment, right? So how is the offset again taken? Okay, take BP content, take SI content, take the displacement, add them together. You will get a value to be used within the stack segment, or it will index into the stack segment. So the offset points to this location. So move the content of this location to AL. So that's how based index plus displacement addressing mode works.